So I'm a senior site reliability engineer and FinOps practitioner. So I work across yeah, different applications, different teams. On the SRE side, we have a group within IT that's called Cloud One, and really what Cloud One is, it's a collection of people, it's a collection of technologies and automation that we use for standardizing our environment, whether it's on the infrastructure or container side. We provide automation and services that allow people within IT or application developers to go through and request VMs, whether they're on-prem or in the cloud through a portal. They have full control over, where it's going to go, whether it's on-prem, if it's an OCI, AWS, it's all options that they have. And then with this, it's standardized because it's all automated. So tags are all consistent across it, access controls, things like that. So it's a collection of people and technologies, and most of the focus is around infrastructure as a service, load balancers, VMs, and then the containers. First, we're going to talk about what is Spot, what is an Elastigroup, and then we'll get into our usage of it, and then Spot Ocean, which is the Kubernetes component, and then Spot Eco, which is a way to manage our eyes. So what are Spot instances? A lot of people, they hear about Spot, but you don't really know what it is. When you launch in EC2 in AWS, you just go to the console and you don't really click much. You're going to have an on-demand instance, which that really means it's going to keep running until you shut it down, or in the rare event that Amazon has to do maintenance on that rack or that hypervisor, they'll send you a notice, tell you to shut it down and restart it. And so, I mean, that's on demand. It's always running, just like something that would run in your virtual center if you have VMware. A Spot instance, so Amazon has capacity for their busiest day of the year. The rest of the year, that compute is just sitting around idle. So what Amazon's done is they've reduced the rate of their excess capacity to try to essentially gain some money back on compute that's just sitting there most of the year. They do it at a discounted rate. The caveat is if they want it back, if they need that capacity, they'll give you a 2-minute notice, and then they just take the EC2. So, I mean, it's just like on demand, but you have that, you can lose the instance. And you do save a fair amount of money. Amazon claims it's up to 90%. I think you're doing good if you're around 60%. And it really varies by what region you're in, which AZ, but still 50-60% is way better than the on-demand price. I'll probably say, when you hear me say Spot, I'll try to clarify whether I mean Spot IO or the actual Spot instance, because we tend to internally use Spot a few different ways. But in Elastigroup, it's really the building block within Spot IO. There's a couple other products that are based on it, and under the hood, it's an engine for managing your Spot instances, so that as far as the consumer goes, if you go through that termination where Amazon reclaims it, it'll go through and recreate everything how it was before. And from your EC2 perspective, it's really looks like the machine went through a reboot. It was shut down and booted back up. And so whatever state you were when you shut down, that's the state you'll be when you're out. One of the things Elastigroup gives you is predictive replacements. They have machine learning in place that they watch the replacements happen within AWS or all the hyperscalers. But for this discussion, it'll be focused around AWS because that's what we're using. So they'll watch what's happening with AWS, and they'll figure out, oh, this instance is going to be replaced or likely to be replaced. So they'll preemptively replace that instance up to an hour ahead of time before Amazon would do it, which allows you to run any scripts to quiesce the machine, allow for any transactions to complete. Just gives you more time, and so you don't have that 2-minute window from when you get notified and power goes away. The Elastigroup, as far as the options go, it's a combination of what you would see with when you're going to launch an instance in Amazon. So like EC2 run instances, some of the components of an auto scaling group, because an Elastigroup isn't just one EC2 instance, it can be one or more. And when you have more than one, you can have different components in it that for scaling, you can tie it to a load balancer. So it's really that marriage of like the run instances and auto scaling groups. It has a little bit more, but that's the core of it is really that functionality. With Elastigroups, you kind of have three options for how the engine manages your instances. You could be completely ephemeral, where it just creates new instances based on the AMI and user data, or you can, the other two, which are ones that are more likely to be used, are where you reattach the EBS and ENI to the same, not to the same instance, but you just reattach those. So you're locked into the same AZ because you can't move ENIs or EBS volumes to different AZs. The other approach is where the Elastigroup is creating AMIs in the background, so that if there is a termination event, it can create the instance in a different AZ in that same region because it's AMI based instead of EBS and ENI. That's really what we're going to get into here, is those two different scenarios. So in this case, we have a EC2 that's running, it's going to be terminated, and this is with the reattach. So first thing that happens is the EC2 gets shut down, the volumes get detached, the ENI get detached, and then when the new instance comes up, it makes use of those same volumes in ENI. So you can preserve your IP, everything looks and feels the same. Again, it's just going through that shutdown process and boot back up. And internally, we use this a lot, and I'll cover it later on, but there's technical reasons why we're doing it, that we want to change why we're doing it this way, because we want to be able to move across AZs, because the spot pricing changes across AZ along with availability. But this is our model today that we're using. The other approach would be the AMI. So again, you have your EC2 in the background. Elastigroups are going through and creating snapshots of your EBS volumes. It starts out with an initial snapshot, and then a snapshot from 5 minutes ago and 10 minutes ago, and it keeps updating those last two snapshots, so that when it goes to create the AMI, it's pretty quick because it's not waiting for the snapshot to complete. It's only a small delta. So in this case, the EC2 is terminated, and we have new EC2, and this can be in a different AZ in that same region because we're creating it from AMI, and it just gives us more options with this. I have a couple screenshots just from the dialogue to help understand what you can do with an Elastigroup. So when you create an Elastigroup, you specify what instance, not just types, but sizes that you want to use within the Elastigroup. And I mean, in this example, it's multiple T's, but they're all small instances and M. But you could really just, whatever you think you need to have in here, you can go through and set it up. You can change it, and they have it broken down by the different categories of instant families. And then if it's possible that there may not be any spotted instances available in the AZ that you're running in, and that's where this combo box in the top right here comes into play. So if it falls back to on-demand, you specify what that instance type is. But if you may not never end up on that, depending on how you configure your Elastigroup. And with this, I wanted to show how you can specify what AZs you're running in and what subnets, and based on that, Spot.io will go through and create this chart on the right, where it tries to figure out the score for the different AZs and instance types, what's likely to be available, what's not, and they just color code it. And so we have that list of instance types that we want to use. You can also have a subset of that list. You can say, okay, here's my list I want to use, but I really want to use these 3 or 4 instance types, and you can control that. So again, in this case, what we're saying is try to use these 4 instance types on the right there before using the other ones. And this list is what you've selected in that previous dialog. So you're just picking a subset, and then it's also doing the scoring for those. The instance lifetime, when you're in the wizard, it's not a guarantee that if I pick 24 hours, it's not a guarantee I'll have the instance for 24 hours. But what Spot does is Spot.io does is try to find the instance types and AZs that they've seen that have that lifetime, so that you're not interrupted, or less likely to be interrupted for that duration. Okay, so how are we using Elastigroup? So within IT and Cloud One, we have a ServiceNow portal where application teams and folks within IT can go through and request VMs, essentially. I say VMs because it's hybrid. When you go through and you want one in let's say AWS, if it's non-production, it will automatically be a Elastigroup, so it'd be a Spot instance. You can go through and change it if you want, but people can open a ticket to have it changed. So it's something that can be changed, and if you change it from a Spot to an on-demand, you're really just going to go through what feels like a reboot process, because you're going through that same termination process to move it from a Spot instance to an on-demand, or vice versa if you're going that way, where the instance gets shut down, depending on your settings, things get saved or an AMI created, and then a new instance comes back up. So if you're moving from Spot to on-demand or on-demand to Spot, the new instance will be based on what you specified. And we also have something we call smart parking, which is Ansible based, that will, during off hours, I think the default schedule we have for instances, weekends, shut them down. And all that does is makes the call into the Elastigroup to say, instead of being a max size of 1, set it to 0. And effectively what that'll do is you go back to those animations we looked at a few slides back. You end up with either an AMI saved off or the EBS and ENI saved off, so that when you change it back to 1, it just reuses those and makes it look like it was when you changed it to 0. This is an example of how we're saving money between using Elastigroups and with our smart parking. So on the top of both sides is, it's hard to calculate the numbers of what it costs to have on-prem compute, because you have to look at the hardware, the networking, the operations time that's put into it. So many factors go into it. So some smarter people than me figured out a scheme to figure out the prices of stuff, and internally that's kind of what we came up with for an instance along this size. What you can see on the bottom left is, so if we're running just with Spot, it would be like $189 a month. With smart parking, where it's running for 12 hours a day, 12 hours a day, seven days a week for all year long, where it's shutting down for that additional 12 hours every day, we're saving $94. In the case on the right, same scenario, except it's running weekdays and it's shut down on weekends. It ends up saving $54. So I mean, it's even just shutting things down during off hours, if you can, it saves a lot of money, because all this adds up. We're just looking at a single instance here. We have over 1,000 in our IaaS environment alone. So benefits we've seen, first thing, savings. So we've seen between 30 and 50% savings over on demand. I'll tell you, it really varies on the instance type you're using, the region you're using in AZ. It really vary. You'd probably see fewer savings with T family instances versus like an M, C, or R, just because T's get used a lot, and then with the ability for it to burst, people tend to use those a lot. So when you do fall back to on-demand, if there's no capacity for or spot instances available for what you're using, Elastigroups can make use of RIs, reserved instances and savings plans that you've already purchased. So instead of just using a instance that, on-demand instance, you can get some additional savings by using the RIs and savings plans if there's any capacity left in those. You can create on-demand and spot Elastigroups. They're the same way. When you're in the wizard or modifying them, it's really just a slider to control how much of the Elastigroup is spot versus on-demand. So it could be 0% spot, which would make it everything on-demand, or go the other way, or anywhere in the middle. And so it definitely gives you some options. So you can have, if you have multiple instances running, you can do a mixed workload where some of the instances are spot, so you get some savings, but maybe you want to have some consistency within the resources you're running, and that you can buy that with the on-demand instances. So really a lot of options in there that you can do. I think all the bullets on the right I've already covered. Where you can convert them, and the predictive rebalancing or replacement is, that hour really gives you a lot of options there. To really make the most use of it, here's an agent that you would need to install on your EC2s, which all it's doing is it's pulling the Spot.io production instance and just checking to see if there's a replacement. If there is, it'll just invoke whatever script you've told it to. So challenges we've seen, in our case, we're not spanning AZs. It's we can solve that problem. The issue we have is DNS and CMDB. We don't have anything that creates it on the fly. When we're provisioning the Elastigroups, we're creating the DNS entries and CMDB entries through other tasks within the playbook. So it's not something within the Elastigroup or any of the user data for it. Once we solve that, which is something we can do when the instance boots up, at that point we'll be able to span AZs. But right now that's a big challenge, because once an instance gets created, because you're preserving the EBS volumes and everything else, you're staying in that AZ forever. So the only way to get out of that AZ would be recreate the instance, or create an AMI from the instance, and then create a new Elastigroup with that AMI. The spot savings, they definitely vary, and there's been a trend with certain instance families where the rate of savings has decreased over the last 6 to 9 months. So it's really useful to go through, when you're creating Elastigroup, specify as many, not just instance sizes, but instance types that you can, that cover your workload needs. That way you're giving more data to the engine on the back end to make decisions to save you more money. We've been using Elastigroups for, say, 3 to 4 years now. These are the challenges we've had. It really isn't much. Most of these are solvable one way or the other. The only challenge is its excess capacity. So when you get closer to the peak times for the hyperscaler, you're going to see more interruption rates. In the case of AWS, that tends to be around November and December. So at that point, you might fall back into on-demand more often, or see more interruptions. And it's worth noting too that you have to think about what you're going to be running on the spot instance, before you go through this process. If you're running a database, you really need to think about it more than maybe like a web server, because web servers you don't really care about because they're everything's usually static, or you could have multiple
Yeah.
web servers without much effort. So it really depends on your workload. Some workloads are better than others in this. Okay, Spot Ocean. So essentially, Spot Ocean is, and it does more than this, but the big thing it does is it's an engine for managing your worker nodes in your Kubernetes clusters. Your clusters could be OpenShift, could be EKS, it could just be running on EC2 instances, a bunch of different options there, but it's managing your worker nodes. Ocean does more, but that's its bread and butter is the managing the worker nodes. It does it by right sizing and bin packing the worker nodes. So let's say you have 100 CPU worth of pods running in your cluster, and you have 120 CPU in your worker nodes. What Ocean's going to try to do is move all the pods down into as few worker nodes as possible. And maybe as part of that, it would replace nodes. Maybe it would replace with a bigger node or smaller node. But it's going to get down to what the capacity is that you're using in the cluster. So let's say it gets down to where it matches the pod CPU usage, at that 100, and then another pod gets deployed. Ocean will spin up a new worker node to handle that the capacity for that pod, and if it needs to, it'll then go through and also bin pack that. Again, the bread and butter is the management of the worker nodes, and anyone that's spending time managing worker nodes in Kubernetes, it can take some time, automation or otherwise, and it really simplifies things. Under the hood, or not even under the hood, the way you manage the worker nodes is through what Spot.io calls virtual node groups. It's really just in this case, it's a AMI, block device mapping, some tags, labels. What it really buys you, you can run most of your cluster on Spot, and then any cases where like you need an on-demand instance, you can have a separate virtual node group with a label and taint, so that if a deployment uses those, it can run on on-demand instances, and Ocean would just create the on-demand instances when it needs it. So you wouldn't have if there weren't any pods. And again, that kind of goes back to the database discussion where, like Mongo it can handle interruptions, but it doesn't like a lot of interruptions because it takes a little bit for it to quiesce, and then your application's held up while it's waiting for the database to quiesce and do the leader election. This is just kind of a diagram of what happens when the nodes get replaced. Typically what you would do, or historically what you would do, is you would cordon a node, which all you're doing with that is saying, don't deploy any more pods to the worker node. Ocean would then spin up a replacement node, wait for that to be in the cluster and available, and then it would drain the node that's going away. So that would force all the pods off of that node to elsewhere within the cluster, which a lot of that should probably land on the new worker node that's coming out. Scale up, scale down, it's all automatic. Ocean just manages it for you. It's super easy. You don't have to think about it. I can't tell you how many hours or days I've spent on scale up, scale down automation. It's in the past, it's not fun to do, and it's really nice that they do this for you. So real quick, just to show you a couple of screenshots from Elastigroup, or not Elastigroup, from Ocean. So you can see here, we have different virtual node groups. You can call them whatever you want. And we have a scheme that we use to help identify them. So you can see, we have some on-demand nodes in our virtual node group for on-demand nodes. You can also tell here it's on demand versus spot, how many pods are running, how much load each worker has. You can define headroom within Ocean. So like these areas here, the reserve capacity within that worker node. So if new pods get deployed into the cluster, you're not waiting for new EC2 instances to spin up. It's going to use that capacity that you've told Ocean to carve out, and then it might still spin up additional worker nodes, but it won't cause your new deployment to be waiting for them, or depending on how big that deployment is. So benefits, the savings we're getting between 51 and 58% savings, and we've been using it for a year and a half in production. So I mean that's pretty good. We're not using T's or the T family. It's mostly MCs and R's, so that definitely helps with our savings. The scale down, it's smart enough so if the cluster is full, there's no capacity, and you make a deployment that has, let's say, 3 replicas, anti-infinity, which means each pod's going to run on different hardware. Instead of spinning up an individual node to handle that capacity and then realizing it needs 2 more, Ocean will just create all 3 workers at the same time to handle that workload that's been sent to or been deployed to the cluster. You can also do management of this is another thing we spent a lot of time with was the patching of the worker nodes. Our worker nodes are ephemeral. We just go through and update AMI and then roll the cluster. So Ocean makes it really easy to do the updates. You update the AMI, you go to this one dialog for cluster roles, give it a percentage of the cluster you want to work against at any given time, and it'll replace all the nodes. So if you have 100 nodes in your cluster and you give it 10%, it'll replace 10 at a time, wait for all 10 to complete, move on to the next 10. And that's your patching for your cluster.
Cool.
Or if you're moving to new Kubernetes versions, you need to go through and do something like that to ensure you're running the right versions. It also has reporting. This is a aggregate view of all of our clusters. So it's maybe first or second week into the month, so you can see where we're saving, so you get a view of that. The efficiency we'll talk about in a second ties into this right sizing that you can see here, which we'll also dig into in a moment. So you can see pricing by namespaces. So we have this namespace here, so you can see the prices for that. And then you can also expand that out to see the individual deployments or replica sets in that namespace and how much they're consuming. Right sizing is a big thing. So you see these two lines. On the left is CPU, right's memory. This is how much has been requested as far as the pods go. This is how much is actually being used. So all the space between here is wasted resources. And Ocean's good about reporting that. So you can see here for this one, someone made a deployment into Kubernetes thinking it was a VM because they have 4 CPUs, and they're consuming such a fraction of a CPU, and same thing for memory. So help get those lines closer together, save some money by seeing the right sizing data from Ocean. This was a hard slide because we don't really log into the Spot console that often to do anything with Ocean. It just, we have it set up, it works, and the only time we really have issues is when there's an underlying hyperscaler issue. We haven't had any issues with it. The one thing I'd say is, before you go through and create a cluster, think about how you're going to manage the cluster. And when we created our clusters, we used a tool called EKS CTL, which created our clusters, but it didn't really help with the day 2 operations. So what we ended up doing was using Terraform on our virtual node groups. Because if we use Terraform on the cluster, first thing Terraform would do is delete the cluster and then recreate it. And we didn't really want that to happen. So the alternative was just to manage the virtual node groups. So that's something to think about as you're going through and creating an Ocean cluster. We have a product that has it's licensed that it has node-based licenses, and we're working with the product team to find a way to manage that. We can set a limit on the size of the clusters, which would solve our problem, but it would run into an issue with the scaling. So we're just trying to work with the product team to figure out the best path there. And then that's a recent issue from a product license renewal. The last thing I'd say is, if you're depending on your involvement of your security team, you may end up needing to create different AMIs for your worker nodes. Amazon provides EKS worker node images, but they're likely going to be flagged by your security team as needing some changes. So the best way to handle that is to make your own version of the worker nodes. And we have a custom process for creating the AMIs every month. And the last thing I want to talk about was Spot Eco. I've been unlucky and had to manage RIs before there was tooling to manage it for you, and it's not fun. You're making 1 or 3 year commitments to the hyperscaler, and you're really doing capacity planning for them. You're saying, I'm going to use this. You're looking at RIs. You're saying, I'm going to use this instance type and size in this region, for 1 year or 3 years. Or if you're looking at savings plans, you're saying, I'm going to use this amount of compute. It could be in a region or it could be globally, but you're committing to it in a 1 or 3 year commitment. So it's a cost savings measure. It's not an actual instance itself. All you're doing is, again, you're doing capacity planning in this case for AWS, and by giving them that commitment, they're giving you a reduced rate on the on-demand instances. In our case, we set it up a couple years ago. When you set it up, you have to work with the Spot team. They ask you some questions like, how much of your bill do you want to have covered by RIs, things like that. And once you set it up, you probably just need to look at it once a year just to see if any of those values need to be tweaked. I don't think we've looked at it in a couple of years. We need to. The graph on the right shows kind of like the ideal situation where if you're doing everything in on-demand, you want to have a bunch of different options for your savings there, whether it's savings plans or RIs. Eco kind of handles that top 68%, I think it is, in that graph, where it'll automatically buy and sell RIs for you based on the usage within your AWS organization. You don't need a bank account, which is a challenge for a lot of companies. It'll just see, okay, you're not using this RI anymore. It'll turn around and sell it, figure out what you're using, try to buy it, so you can get that coverage. We're seeing within IT about $21,000 savings every month from Eco managing our RIs. Takeaways: Elastigroups, they manage working with Spot. So I mean, you don't have to worry about trying to reassemble things or trying to have an instance have a bunch of user data or automation to get it in that state. It'll put that instance back together. Ocean, in addition to the savings, there's just the scaling and cluster roles that just from a platform engineering perspective or SRE perspective is awesome. And then for the optimization, you have the reporting and the right sizing. And Eco, it's just you set it up and check on it every year or two, and it'll just save you some money.